Hello everyone, this is Sravanthi, working as Assistant Professor of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss the topic is secondary batteries. So in this topic, I am going to discuss what is secondary battery, how to construct lead acid storage battery, nickel cadmium battery and lithium ion battery. So first, what is the meaning of battery? Battery is a device in which two or more electrochemical cells connected in a series is called battery. Two or more electrochemical cell means each cell it consisting of one anode and the one is cathode. So this combination is called cell. So already we know that at anodic area oxidation reactions takes place. Oxidation means loss of electrons. At cathodic area reduction reactions takes place. Reduction means gain of electrons. So battery means it is a device in which two or more electrochemical cells connected in a series is called battery. So here one electrochemical cell means it containing one anode and one cathode. So two or more electrochemical cells means it containing two or more anodes and two or more cathodes. It is called battery. So batteries are classified into two categories depending on their rechargeable capabilities. So these batteries are classified into two types. One is primary battery and second one is secondary battery. So what is primary batteries or primary cells? The cell reactions are not reversible. Once reactant converts to the product, it becomes dead. The type of batteries are called primary batteries. Here, the cell reactions are not reversible. These batteries are called primary batteries. Here, only reactions takes place one-way direction. Once reactants converts to the products, we cannot use again because these are not rechargeable batteries. Here, once reactant converts to the products, it becomes dead only. And these primary cells cannot be recharged and reused. The best example of primary cells are dry cell or Leclanche cell and lithium cell or alkaline battery. And these batteries are mainly used in torches, radios, transistors, etc. So these simply basis primary batteries are we cannot reuse. These cell reactions are not reversible. Is called primary batteries. So already we discussed how to construct dry cell and what is the working function, where we can use, all we discussed in last class already. So now let's discuss secondary batteries. So the secondary batteries or secondary cells means the cell reactions are reversible. The cell reactions can be reversed by passing electricity in opposite direction. So secondary batteries means the cell reactions are reversible by passing electricity in opposite direction. These batteries are called secondary batteries, and these batteries we can use so many number of cycles, charging and discharging. Once we are using completely these batteries, again we can use by recharging, by passing electricity in opposite direction. This type of batteries are called secondary batteries. Best example of secondary batteries is lead acid storage battery, nickel cadmium battery and lithium ion batteries. These are the best example of secondary batteries. And generally these batteries are used in automobiles, cars, trains, motors, electronic clocks, power stations, laboratories. So many ways we are using these batteries. So first we discussed lead acid storage battery or lead acid cell. It is the best example of secondary battery. So in this battery, anode is lead plates. So lead plates acts as anode, lead dioxide plates acts as cathode, and electrolyte is dilute H2SO4. 20% of H2SO4 acts as a electrolyte. So how to construct this lead acid storage battery? Here, lead plates are arranged in parallel. Lead plates are arranged in parallel and lead dioxide plates also arranged in parallel. For example, here, this is a setup of lead acid storage battery. In this we are taking dilute H2SO4. Here dilute H2SO4 acts as electrolyte and next lead plates are acts as anode. So here These lead plates are access, anode, and lead dioxide plates. These are also arranged in parallel. These are access, cathode. So this total setup is dipped in dilute H2SO4. So how to construct this lead acid storage battery? It is the best example of secondary battery. Here in this battery, lead plates are access anode, lead dioxide plates access cathode, and electrolyte is dilute H2SO4. So here, lead plates are arranged in parallel and lead dioxide plates also arranged in parallel direction, and this total setup is dipped in dilute H2SO4, and these anodes and cathodes are separated by adjacent one by separator like glass, rubber, or glass fiber used as a separator. So this is the construction of lead acid storage cell. So here just now we discuss. So if number of cells connected in a series, so that arrangement is called battery. Here the lead acid storage battery is most common battery which is used in automobiles. And here anode is made up of lead and cathode is made up of lead dioxide. So all anode negative plates, anode means, so all are arranged in parallel direction, and cathode positive plates are also made up of PbO2, and these are also arranged in parallel, and these two are separated by adjacent one by glass or separator, glass fiber or rubber used as a separator. So this total setup is dipped in dilute H2SO4. It acts as a electrolyte in this battery. So this is lead acid storage battery. So here lead plates and lead dioxide plates, and both are separated. Here positive plate is lead dioxide acts as cathode. Here negative plate, it acts as Pb, it acts as anode, and these two are separated by separator. So this is lead acid storage battery, and in this battery its density is 1.30 gram per ml, and this battery is represented as lead. It acts as anode, and when it is undergoes oxidation then form PbSO4 precipitate at anodic area. These two parallel lines indicate salt bridge. These two parallel lines is salt bridge, and H2SO4 is the electrolyte in this battery. It acts as electrolyte, and PbO2 it acts as cathode. So when it is undergoes reduction, it gives Pb plus 2 ions. When it is reacts with sulfate, then form PbSO4 precipitate at cathodic area also. So this is the representation of lead acid storage battery. So it is one more diagram of lead acid storage battery. Here this radical line indicates Pb acts as anode, and here blue color lines indicates PbO2 lead dioxide, it acts as cathode, and these two are separated by separator. Yellow color line indicates this is separator. Generally we are using glass, fiberglass or rubber used as a separator, and this total setup is dipped in dilute H2SO4. So working function of this lead acid storage battery. So in this working function we will discuss discharging first. Discharging, when we are using this battery will be low generally. So in this case at anodic area, so which one is acts as anode in this battery? So lead acts as anode. So in this discharging function at anodic area, lead undergoes oxidation, then gives lead metal ions and loss of 2 electrons. So this lead metal ions reacts with sulfate, then form PbSO4 precipitate. PbSO4 precipitate formed at anodic area. So during discharging function in this battery, lead acts as anode. So at anodic area generally takes place oxidation reaction. Oxidation means loss of electrons. So lead undergoes oxidation, then gives lead metal ions and loss of 2 electrons. So this lead metal ions reacts with sulfate from the electrolyte. So lead metal ions reacts with sulfate from the electrolyte, then form PbSO4 precipitate at anodic area, and it is a oxidation reaction. So loss of 2 electrons. So next at cathodic area. So generally at cathodic area reduction reactions takes place. Reduction means gain of electrons. So here PbO2 acts as cathode. So PbO2 undergoes reduction, that means gain of 2 electrons, and it also reacts with H2SO4 from the electrolyte. So it reacts with 4H plus and sulfate from the electrolyte. Then it forms PbSO4 precipitate at cathodic area, and water also byproduct it forms. So combining these two reactions, one can be determined the overall reaction during discharging process. Pb acts as anode, PbO2 acts as cathode, and the sulfate H plus from the electrolyte. Then it forms PbSO4 precipitate formed at anodic and cathodic area. Here one PbSO4, here one PbSO4. So total PbSO4 precipitate formed at anode and cathodic area. That's why here we are reading 2 PbSO4. And byproduct is 2H2O and loss of energy. When we are using battery, generally charging will be decreases. So loss of energy. So in this case, the battery needs charging. So here, so cell reactions during recharging. So when we are using battery becomes low during discharging process. So in this case, the battery needs charging. That charging means passing electricity opposite direction in this battery or in this cell. So here, the reaction will be reverse. So here, PbSO4 plus H2O when we pass electricity opposite direction in this charging. So in this case, Pb deposited anodic area and PbO2 deposited cathodic area, and concentration of H2SO4 also increases. So here, notice how the charging reaction is exact opposite to the discharge reaction. This is the main thing. So one more important point is during discharging process when we are using battery, so here concentration of H2SO4 is decreases. During discharging process, H2SO4 concentration is decreases. So in charging cases, concentration of H2SO4 is increases. Which is a very important point in this lead acid storage battery. So what are the advantages of lead acid storage battery? So it made easy. It easily can construct and they produce very high current. And the self-discharge rate is low when compared to other rechargeable batteries. And it also acts effectively at low temperature also. These are the main advantages of lead acid storage battery. And what is the disadvantages of lead acid storage battery? So here, recycling of this battery causes environmental hazards. It's the main drawback of lead acid storage battery. And mechanical strain, normal bumping reduces the battery capacity, reduce the efficiency of this battery. This is the main drawback of lead acid storage battery. And where we can use this battery? This battery is mainly used in automobiles like cars, buses, trucks, okay, and also used in electrical vehicles, gas engine ignition, telephone exchanges, electrical trains and mines, laboratories, hospitals, power stations, automobiles. So many cases we are using lead acid storage battery, and its voltage range is 6 to 12 volts. EMF of this battery is 6 to 12 volts. So second type of battery, best example of this secondary battery is a nickel cadmium battery. So one of the example of secondary battery. Here anode is cadmium. In this nickel cadmium battery, cadmium acts as anode. Here generally we know that in electrochemical cell, anode is having negative charge, cathode is having positive charge. So here at anode, in this nickel cadmium battery, cadmium acts as anode. And cathode is nickel hydroxide, NiOH2. Nickel hydroxide acts as cathode in positive plate. That means cathode charge is positive charge. Or otherwise it is also called nickel oxyhydroxide or nickel hydroxide acts as cathode. And electrolyte is generally we are using aqueous KOH or NaOH used as electrolyte in this battery. So in this nickel cadmium battery, it is the best example of secondary battery, and here anode is the cadmium and cathode is nickel oxyhydroxide, and electrolyte is generally we are using aqueous KOH or NaOH used as a electrolyte. So during working function, what are the cell reactions takes place during discharging process? So at anodic area, so in this nickel cadmium battery, cadmium acts as anode. So cadmium undergoes oxidation, then forms cadmium metal ions when loss of 2 electrons. So this cadmium metal ions reacts with OH minus ions from the electrolyte, then form cadmium hydroxide and loss of 2 electrons because oxidation reactions takes place at anodic area. Oxidation means loss of electrons. So at cathode, so generally nickel hydroxide or nickel oxyhydroxide acts as cathode. So cathodic area reduction reactions takes place. That means gain of electrons. So nickel oxyhydroxide or nickel hydroxide reacts with H2O and gain of electrons. Then it forms nickel hydroxide NiOH2. Here it is called nickel oxyhydroxide. Here nickel hydroxide form and byproduct is 2OH minus. So overall cell reaction during discharging process in this nickel cadmium battery, cadmium acts as anode and nickel oxyhydroxide acts as cathode and it forms cadmium hydroxide and nickel hydroxide formed at anode and cathodic areas. So the reaction, just now we discussed already anode oxidation and reduction reaction, and this is an overall reaction in this nickel cadmium battery. Here the reaction can be reversed because it is a secondary and rechargeable battery. And because the reaction product cadmium and nickel hydroxide are adhesive to the electrode surface of nickel cadmium battery. And it has fairly constant voltage. Its voltage is 1.4 volts. It is nearly less than 2 volts. And these are recently developed portable rechargeable cells. Easily we can recharge and it can be left for long period of time and without any appreciable deterioration, since that means no gas produced during charging and discharging process. This is the main advantage of nickel cadmium battery. So where we can use this nickel cadmium battery, it is used in calculators, digital cameras, laptops, recorders, flash phone, medical devices, electrical vehicles and space applications. So in this case we are using this nickel cadmium battery. So what are the advantages of nickel cadmium cells? So here this battery operates both as voltaic cell and electrolytic cell. Voltaic cell means it is also called as electrochemical cell, that means which converts chemical energy into electrical energy. It is called voltaic cell or electrochemical cell, and it is also acts as electrolytic cell, that means it converts electrical energy into chemical energy. This is the main advantage of nickel cadmium battery. So it operates electrochemical cell as well as electrolytic cell, and it has the potential range is 1.4 or nearly it is less than 2 volts and low cost, used at low and high temperatures, and good performance in low temperature, long life period. It should produce long shelf life. This is the main advantages of nickel cadmium battery. Now discuss here disadvantages. So here it is very costly, highly expensive than other batteries, and low average EMF. So therefore more cells are required for the particular voltage. So this is the main drawback of nickel cadmium battery. Now discuss one more example of secondary batteries, lithium ion battery. So already we discussed last class lithium battery. That lithium battery acts as primary battery. So lithium battery is the best example of primary battery. Here lithium ion battery is the best example of secondary battery. In the primary battery, lithium acts as anode and in titanium sulfide acts as cathode, but that is not rechargeable batteries. But here lithium ion battery or it is a best example of secondary battery. Here lithium not acts as anode, but lithium ions are responsible for charging and discharging process. So that's why this battery is called lithium ion battery. So it is the best example of secondary battery. In this lithium cell, it does not containing metallic lithium as anode. So here, so just now already we discussed why this name suggests this battery, lithium ion battery. Lithium ions are more responsible for charging and discharging. So that's why these cells are called lithium ion batteries. And in this battery, cathode is layers of lithium metal oxide. In this battery, cathode is lithium metal oxide. So in this battery, generally we are using metal cobalt, lithium cobalt oxide used as any metal we are taking. But here I am using lithium cobalt oxide acts as a cathode in this lithium ion battery. Here layers of porous carbon, it acts as anode. And electrolyte is polymer gel. And permeable membrane like glass or rubber used as a separator. That is used for mainly which allows the lithium ions from anode to cathode and cathode to anode. That purpose we are using this separator through this polymer gel, and it allows the only lithium ions, not that of electrons. Electrons move to the external circuit. So how to construct this lithium ion battery? So here positive electrode, that means cathode. It is made from layers of lithium cobalt oxide or any other lithium metal oxide. And negative electrode is made of from layers of porous carbon, that is graphite. And both the electrodes are dipped in polymer gel electrolyte. It acts as a electrolyte like organic solvent like ethanol, methanol, etc. And separated by a separator, which is perforated plastic and allows the lithium ions pass through. So here anode is the layers of porous carbon and cathode is the layers of lithium cobalt oxide, and electrolyte is polymer gel, simply using organic solvents. And here we are using separator like perforated plastic or glass. This separator is mainly used for which allows the lithium ions during working function, charging or discharging. It allows the lithium ions from anode to cathode and cathode to anode. But it does not allow the electrons. Electrons move to the external circuit. For example, so first we'll discuss working function charging. So during charging, lithium ions flow from positive electrode to negative electrode. So positive electrode means cathode. So where it is present lithium ions first? Cathodic area only. Cathode is made up of layers of lithium cobalt oxide. So during charging process, lithium ions flow from the cathode to anode. That means lithium cobalt oxide to graphite through the electrolyte. So electrons also flow from the positive electrode to negative electrode to the external circuit. So here the electrons and lithium ions combine at negative electrode, that means anodic area, and deposited there as lithium. For example, here lithium cobalt oxide, it acts as a cathode, and this graphite, it acts as a anode. So during charging process, for example here X amount of lithium ions move from cathode to anode. So here we are writing lithium 1 minus X COO2, lithium cobalt oxide, only X amount of lithium ions move from cathode to anode and deposited there as lithium at anodic area. So this is charging functions in this lithium ion battery. Now let's discuss discharging function in this lithium ion battery. During discharging process, this lithium ion flow back through the electrolyte from anode to cathode. Reverse reaction during discharging. So from anode negative electrode to positive electrode, that means anode to cathode. So here electrons flow from the negative electrode to positive electrode, that means anode to cathode. So the lithium ions and electrons combined at positive electrode and deposited there as lithium. For example, during discharging function, here X amount of lithium ions first charging process move from cathode to anode. Now discharging function, it is reverse reaction. That means that lithium ions move from anode to cathode. So here this is a cathode to anode. Negative electrode to positive electrode. So during discharging function, this lithium ions move back to through the electrolyte from negative electrode to positive electrode. That means from from anode to cathode, and deposited there as lithium at cathodic area. So this is the diagram here. Lithium ion battery. Here anode is the layers of porous carbon. This is the layers of lithium metal oxide. So generally in this metal we are using cobalt. So this total setup is dipped in polymer gel. It acts as an electrolyte, and these two are separated by this is separator. Generally use plastic, percolated plastic, and this separator is used for which allows the lithium ions from cathode to anode or anode to cathode. Here, for example, here during discharging function, so lithium ions are moved from during discharging process anode to cathode. During discharging process, lithium ions are moved from anode to cathode. So here the separator allows only lithium ions from anode to cathode, and electrons are moved to the external circuit. And finally at cathodic area, this lithium metal ions and electrons combines, and there is lithium deposited at cathodic area. It deposited there as lithium. And here charging function. Here also same, anode is the layers of porous carbon and cathode is the lithium cobalt oxide. And here in this during charging process, lithium ions move from cathode to anode. So through the electrolyte and through the separator. So in this separator, here also same thing. Here it allows the lithium ions, electrons move to the external circuits. So finally at anodic area, this lithium metal ions and electrons combine, then it forms lithium ions. Lithium formed at anodic area. Now we'll discuss what are the advantages of lithium ion battery. So lithium ion battery, these are having high voltage. It is nearly 3 volts. It produces high voltage and lightweight batteries. And it is available in different sizes, very small sizes. And it produces 3 times the voltages nickel cadmium battery. And it has one of the mercury effects in nickel cadmium batteries. So main advantage, it is available in different sizes and shapes, and it produces a high voltage than other batteries. It is nearly 3 voltage. It is having more oxidation potential, so it produces more voltage than other batteries. Uses it is, and one more disadvantage is it is highly expensive than other batteries, and it is used in cell phones, portable LCDs, and semiconductors, cameras. For example, button size, it is available in different sizes and shapes. For example, button size lithium battery, it is used in laptops, cameras. Okay, so these batteries are used in cell phones, note PC, and portable LCDs, semiconductors, drive-in audios. So in this case, we are using. So, thank you.
Like, share and subscribe. Hit the bell icon for more updates.